heard, Iran has given up its nuclear stockpile. Now the question that's looming over everyone's head is what to do with those weapons. Well, we have quite a few viable options. The first one is to send them off into space where they will never be found. The second option is to disassemble them, but that would waste a lot of work made by the Iranians. Number 3 is to store them, but of course that would be a potential terrorist target to the Taliban and other such groups. And the fourth option, which the US government wishes for you to accept, is to turn those nuclear stockpile into clean, alternative nuclear energy. The basis of nuclear power is on a molecular level. In atoms, there are two binding forces, nuclear force S and electrical force EM. Nuclear power is a lot better for short distances, but electrical force is better for long distances. While atoms bond, that nuclear force keeps them together. But as the atoms grow larger, it starts to reach the outskirts of the nuclear force and will soon reach the part where the electrical force wins the fight. This is the part where the atoms will fall apart. Uranium-235 is an atom that has reached this point.
Nuclear fission is a way to transfer uranium to energy. Nuclear fission occurs when an atom's nucleus splits into different atoms. We make energy from uranium-235 from injecting a neutron into the uranium-235. With the extra neutron, it becomes uranium-236. After this, the uranium would split to become krypton and barium. In splitting, the uranium releases immense energy. We contain the uranium in water, so that when the energy is released, the energy turns the water to steam. We put the turbine on top, so when the steam rises, it powers the turbine, which then produces electricity. This is an excellent source of energy due to the fact that we get a massive amount of energy while using little area. This is also the most efficient source of energy because it is not reliant on the weather or time of day, such as windmills or solar panels. Fission is the only current way to transfer stored energy in the atoms to pure nuclear energy, heating the water it's in and forcing steam up into steam turbines.
Nuclear fusion is where we combine two atoms so that they bond and release energy. The sun is a natural fusion generator because of its gravitational pull. Since all atoms have an electrical force, the atoms try to repel each other. But because of the sun's massive gravitational pull, it overpowers the two atoms' will to repel and moves them together so that the nuclear force bonds them. For example, we have a hydrogen atom with one neutron and a hydrogen atom with two neutrons. With the sun's gravitational pull overriding their resistance to each other, the two atoms combine. We end up with helium with two neutrons and a leftover neutron, along with an outburst of energy. The sun does this process many times, so that we have a lot of neutrons. The neutrons are sent out in wave and get onto Earth. The real question is, how can we make a fusion reactor on Earth? Yes, we have made a fusion reactor. The catch is that it takes more energy to run that generator than the generator actually produces. With the current technology and science, we cannot make a fusion reactor that gives out more energy than it can take in. Maybe that's in the future.
As you can see, nuclear power is very advantageous and we have much to gain from using it. It is very cost effective and will result in immense profits, so this form of power is a worthwhile investment for you to use. In addition, it gives much more energy than other forms. For example, a kilogram of uranium-235 converted to energy releases approximately 3 million times more energy than a kilogram of coal burned conventionally. This is why you should choose nuclear energy.